Hello everyone, today we are unlocking how computers learn like humans. First, about me. I'm Peter, a 20-year-old senior who codes and shoots hoops. I've been learning computer science for 3 years and have programmed an app on my own. So you may ask, what is actually machine learning? Imagine teaching your dog tricks with trees. Here, we teach computers using data instead of snacks. Back in 1952, a program called Samuel's Checkers shocked everyone by learning from its own mistakes. It proved machines could outsmart humans. Computers learn from data without step-by-step instructions. That's the magic. Now, let's time travel through machine learning's greatest hits. In 1957, the perceptron became the first artificial neuron. Then, in 1986, backpropagation revolution starts. It solved XOR problem, which means neural net rebirth. In 2012, AlexNet wins ImageNet. Deep learning goes mainstream. In 2023, ChatGPT changes everything. Large language models understand human language. ChatGPT chats like your BFF. This tech evolved faster than TikTok trends. Now let's get into the first algorithm, linear regression, predicting the future with straight lines. For example, y equals mx plus b. This is the linear regression formula that predicts outcomes using a straight line. What is y? It is what you want to predict. For example, your math test score. X means the input you control, and m, which is slope, means how strongly x affects y. And b, it means the starting value when x equals to 0. For example, even with 0 study, you would get 40 points. Let's make an example. If m equals to 10 and b equals to 40, if you study 3 hours, then the y equals to 70 points. You may ask why it matters. It's the ABCs of machine learning. Complex AI is built on this logic. Now let's get into the algorithm 2. Decision trees. Should I play soccer today? You can look at this picture. First, you ask yourself, is it sunny today? If the answer is yes, then it goes into, is it humid today? If the answer is yes, then you'll say, okay, let's go and play soccer today. But if the answer is no, then you can see, okay, it's too hot. I'll stay at home. Y is clever, measures human logic, breaks complex decisions into simple yes and no steps. Second, learns from data, could adjust thresholds. For example, humid equals or larger than 60% humidity. Just like choosing outfits by checking, is it raining today? If the answer is no, then you ask yourself, is it cold today? If the answer is still no, then let's wear shorts. Now let's get into the algorithm 3, neural networks, brain-inspired learning machines. For me, neural networks equals to Lego for AI. Think of each neuron as a single Lego brick. If it is alone, then it is simple. If it is stacked, then it becomes powerful. How this works? The input is raw data, enters. For example, your handwritten digit pixels. The hidden layer is the multiple layers of neurons, the stacked Lego. Each layer extracts patterns, from edges to shapes to digits. Then finally, the output is the final decision. For example, the computer can figure out that the handwritten digit pixels is number 5. Weights between neurons adjust like muscle memory. Practice makes perfect. The more examples it sees, the better connections get tuned. To learn machine learning, the software you need is PyCharm. PyCharm is a smart code editor that makes programming easier. First, write code faster. Autocomplete suggests commands. Highlights errors instantly. Organizes files visually. Second, run and debug easily. One-click execution. Steps through debugging. Shows variable values in real time. 3. Perfect for machine learning. Built-in support for libraries like sklearn. Jupyter Notebook integration. Handles data files effortlessly. Okay, now let's move into the actual practice. Yeah, here's PyCharm. Yeah, as you can see, I already installed all the libraries that we need. But if you are a freshman, then you have to install all these libraries you need. To start with, here is an exam score predictor, a simple machine learning demo. As you can see, here's some orange import, which means you use some codes from someone else, which means you don't need to code by yourself. That is great, right? Yeah, because nobody wants to code by themselves if they can. Then here's some simple data, because it's just a demo, so the data is very short, and as you can see, here's 1, 2, 3, 4, 5, which means hours, the starting hours. And here's y, which means the score that you get. Remember, this is an actual data, not the predicted one. Then you'll create your model and train the model. Give this x and y to the model. Then it will train automatically. Now let's predict the new score. Like, it will ask you to input an hour, like how many hours did you study. After you give it the hours, it will predict the score. Okay, this part is just create the image, like how you want your image looks like. And here's formatting, which you define the X label, the Y label, the legend, the grade, yeah, all these things. Then you add prediction test. Yeah, because there should be some text on your chart, right? Now, after all this, you got your chart, and then you have to save the plot to a temporary file. Yeah, here's the picture that you got. Then you show the results to the users and try to open the image automatically. But always remember to create an exception, because there's sometimes that maybe you don't know what happens, but it just didn't go wrong. It didn't go right. The print could not open image automatically. Please view the file manually. Yeah, let's give it a try. For example, I input 4, which means I study 4 hours. So it will give me the predicted scores, which is 75%, which means I can get the 75% of the total score. Yeah, you can see this picture. Here's a straight line, which is the predicted result, and here's all the text that you have already input. Yeah, as you can see, here's a green one. That is my result because I input 4. You can see here, and yeah, as you can see, it's almost 70. Yeah. Okay, so that will be today's teaching. Okay, thank you so much.